Hello, everyone, and thanks for joining the latest webinar from Ontotext. The topic today is hands-on with the JDBC driver in GraphDB, bridging relational queries to the graph world. My name is Yasen Stoikov, and I'm part of the Ontotext marketing team. Joining me today is Tomas Kovachev, who will be the presenter and the speaker today. Few words about him. He is a junior software developer here at Ontotext, and he engages on a daily basis in both backend and front-end development around GraphDB and the Curation 2 project. Before giving the presenting rights to him, I would like to quickly go over a few organizational details that I think are important. First of all, the webinar is scheduled to last for around 45 minutes, including a Q&A session that we will have at the end of this webinar. Currently, all of you are muted, and this is mainly to avoid background noises and to enable Thomas to present without any interruptions. With that being said, you can still communicate with us via the chat box and the question box in your GoToWebinar panel. You can do that directly during any time of the webinar, and we will go over your questions during the Q&A session at the end. The webinar is also being recorded, and a link to that recording will be available to you in a few days after we conclude today. And one last thing, I personally encourage you to ask any questions that might have occurred during this session in order to have a meaningful discussion at the end. Without further ado, I would now give the presenting rights to Thomas, who can begin his actual presentation. Thomas?
Hello, everybody. So today I will be speaking about our new JDBC driver and how you can actually use it to communicate with GraphDB using SQL. So first, let me give you a bit of a background story on why we decided to do it and what's the main idea behind it. Knowledge graphs and RDF as a semantic technology offer numerous benefits, one of which is to be able to integrate multiple heterogeneous data sources into one data warehouse, or also known as knowledge graph. This is due to the fact that RDF as a technology has a schema-less approach to it, meaning that, for example, if you have a generic data set, such as take Wikidata, you could easily integrate it with a very specific data set, such as that of PitchBook, which is a corporate finance data set. This technology, however, requires Sparkle for communication and for querying. However, the benefits of RDF as a technology are currently limited due to the fact that there is a large existing application ecosystem that revolves around SQL and relational databases. We have numerous business intelligence and data science softwares such as Microsoft's Power BI and Tableau, or data processing or engineering solutions such as Spark or other types of ETL software that actually require SQL and communication with tabular data providers such as relational databases to actually process data. This limits the usability of such knowledge graphs and of GraphDB, and for that reason we decided to broaden the use cases of GraphDB and actually create a JDBC driver that translates SQL to Sparkle. So what is this type of translation and how did it happen? Well, Implementing it was a huge challenge, as you could imagine. It involved integrating the Apache Calcite framework, which is a very powerful framework, and it is the equivalent of RDF4J, but for relational databases and SQL. From it, we use the SQL parser that translates client's SQL query to an abstract syntax tree, which is processed by Apache Calcite and translated into a SPARQL query for GraphDB engine. From there, we use the SQL execution engine to actually return the SPARQL result as a SQL result. And in order for this to happen, we needed to integrate a SQL table abstraction, something to abstract the SQL table view. In order to do this, we were inspired by the SQL view and the idea behind it, and we created a SQL view by integrating a SPARQL select query result as a SQL view, meaning that each SQL view is actually being represented as a SPARQL select query, a saved one. In order to do this, we also needed to map the RDF to SQL types, which also I will talk about more in over the next couple of slides. From this graph here, you could see the actual architecture of the JDBC driver. So we have a JDBC client that doesn't actually know SPARQL. It sends an SQL query through the Avatica protocol, which is an RPC protocol, which is then processed by the GraphDB server, where Apache Calcite builds the abstract syntax tree using the SQL parser. It then gets translated to a SPARQL query based on the SQL view that it was named after, and then it gets processed by the GraphDB engine, and the result gets returned through the SQL execution engine. So let's delve in a bit more about the technicalities of the JDBC driver. Currently, we support the entire SQL 92 syntax, plus some other default options that are provided from Apache Calcite. For the RDF to SQL type value mapping, we provide the best effort basis, meaning that, for example, if we have a value that is supposed to be a long number, it will be converted to the SQL type long as it matches the type. However, if it doesn't, it will be set to null. In terms of query optimization, we take advantage of GraphDB's engine and more importantly of the GraphDB indices. How this is achieved is by pushing down where clause operations from SQL down to SPARQL. The currently supported operations that are optimized include equality, where clauses, nullability, and text search. Those include some examples such as equals, more or less, is no, is not no, like or similar to, and others. For these optimizations to happen, one operand of the where clause must be a SQL column, and the other one must be a constant. So to get into a bit more detail about how this complexity is being pushed down to SPARQL, here is an actual example by two extracts. In the upper corner here, we have a extract from Microsoft's Power BI custom SQL tab. So here we have our driver, and while we are connected to it, I've implemented a small custom SQL query. So I want all of the SQL columns from test.personalData. Test is actually the name of my repository where I've saved the SPARQL select query, that is the abstraction for the SQL view. And here we have a simple where clause where we have a constant male, and we are actually looking for gender in terms of personal data, male. We can see how this clause is actually being pushed down to SPARQL as a filter clause right here. This is done for the simple reason that standard SQL operations would usually, what would usually happen is they would take the entire data set and they would filter throughout all of the different results, and from those results they would only take the given subset that requires. So for example, let's say that we have a data set with 100,000 results, and those are ranging from year 20 to year 2020. And let's say that we want out of those results to only have the results for year 2020, which let's say are about 100. If we use the standard SQL approach without the query optimization that we provide, we would return the entire data set to Apache Calcite, where we would filter throughout these 100,000 results and return those 100. While by pushing down complexity down to Sparko, we take advantage of GraphDB's engine and most importantly, GraphDB's indices. These indices allow GraphDB to actually return the exact 100 results without having to filter throughout the entire data set, meaning that it is much more efficient and much more clean to use. So to sum up, in terms of query optimizations, here you can see how it actually happens again. And here you can see how the SQL view abstraction actually works. So we have saved a Sparko select query, which we have named personal data. And here you can see what SQL columns it actually has inside. So we have ID, we have first name, surname, gender, religion, email, and birthday. So this is how it gets translated from the client's point of view down to the server's point of view. This query optimization also allows for reduced in-memory filtering and allows for a much smoother experience. Talking about query optimizations, we understand that some of you might want to engage in more complex SQL operations such as inner and outer joins. For those, currently we do not provide our own optimizations, so we use the default order of execution provided by Apache Calcite. But we're discussing and thinking about future optimizations where we would be able to push down even more logic down to Sparko without having to return entire data sets and do filtering on those again. However, our current recommended pattern for such complex queries and for such usages is to actually create new SQL views. As those are basically quite easy, you need to write a select Sparko query that has the needed elements to include in the SQL columns, and that would actually take full advantage of those query optimizations that I was talking about, and most importantly, of GraphDB's indices. Furthermore, if you need to do consolidations and such as outer and inner joins, you could also, for example, if you're using Tableau or Microsoft Power BI, you could use their operations where you could define SQL-like primary foreign key relationships between the different tables, and you could actually link them. In terms of configuring and actually using our JDBC driver with GraphDB, you have 2 point of views. So first one is from the server's point of view. How would you actually save those Sparko select queries? So most importantly, you must understand that we have only one step needed from a server's point of view of actually defining those queries, is that you need to write a Sparko query, save it as a .rq extension file in the repository directory, and you're good to go. I'll provide some examples in the next slide, and also I'll demonstrate to you where exactly you have to put the said Sparko queries and how they are actually fetched by the client. So in terms of client's point of view, all you have to do is download the JDBC driver, place it in the right directory, depending on the business intelligence tool that you want to use. Then you have to input the connection parameters once you've opened the tool, and you're good to go. So how does these Sparkle select queries actually look like once they're saved? So we have an example of such an .rq extension file where we have a Sparkle select query defined here. So we have ID, we have sentiment score, fraud score, and customer loyalty defined as the 4 SQL columns that we want to use. Here we have ID defined as a SQL type string, sentiment score defined as a type float, and the same goes for fraud score and customer loyalty. Keep in mind that this comment here and this comment here are actually two very important pieces of metadata. Here you actually can add such options such as not null or also include precision scale, such as, for example, if you want the float number to be limited to 2 or 3 decimal points, etc., etc. Also, you have another very important piece of metadata, which is the filter clause here. This is actually very important because it instructs GraphDB's engine where to place those query optimizations that I've just showed you in the previous examples. So every time, for example, where you have a where equality clause that can actually be optimized, it gets pushed down to Sparkle and placed inside this query right after the filter clause. This is all I have to say about creating and storing RQ files and what's the pieces of metadata inside of it. In terms of our as an overview of the future and next possible ideas in terms of the JDBC driver, I can say that we are planning to create a user interface inside the GraphDB workbench, which would allow you to create SQL views and to manage them, similar to the newly released RDF mapping interface that we have added. So this increases the use case of GraphDB, as right now you can import structured data inside GraphDB through the RDF mapping user interface as well as Ontotext. And you can create an RDFization of it inside GraphDB, benefit from GraphDB's engine and indices, and be able to export it again as tabular data using our JDBC driver. Other future ideas include supporting insert operations to the said Sparkle views, which would actually allow you to import data inside GraphDB. As mentioned before, we're also thinking about query optimizations in SQL based on more advanced operations such as inner and outer joins that would actually allow Apache Calcite to push some of the logic down again to Sparkle. So this is all that I have to say for the presentation today. Now I'll be moving forward to the demonstration of our JDBC driver. For it, I will be using as a use case mock-up data from a major insurance company. So this is a customer data set that was provided through a CSV file. So this was tabular data. We are importing it as an RDF with an RDF map here through tabular onto refine import. Here you can see that we have personal information such as given name, surname, gender, religion, and email or date of birth. We also have the location of the said customer. So we have house number, street, postcode, etc. We also have customer metrics such as customer loyalty, fraud score, and sentiment score. And we also have education information such as university, degree, and enrollment date. That said, first I will be showing you how to configure SQL views from a server's point of view. How do you save them? Where do you place them? And after that, I will show you how to use both Tableau and Microsoft's Power BI to actually connect to GraphDB and get data from it. First, in order to save this data, in order to save those SQL views, you need to open the location of GraphDB. So you go over to Data, Repositories, and here you can see that I have a single repository whose name is test. It can be seen here as well. Now I select test, and here you need to add a folder which is named is SQL. Once you add the said folder, here I have defined 4 different SQL views. So I have client data, I have education, location, and personal data. Let's open client data. Here you can see that I have the set Sparkle query combined with the SQL metadata that is required. So here I have defined that the 4 SQL columns would be string, float, and float for customer loyalty as well. And also, most importantly, I have added the filter optimization clause as well. Other RQ files which would actually represent a SQL view, such as education, include data such as ID, university, degree, and enrollment date. And keep in mind that the name of those RQ files is actually the name of the SQL views as viewed by Tableau and both Microsoft Power BI. So that's all you actually have to do in order to configure SQL views from a server's point of view. So after you write the set Sparkle queries and save them as RQ files, they are directly available, meaning that you don't need to restart GraphDB in order for them to be available for access. So now that we have seen how these .rq files are actually saved as SQL views, I'll be moving forward and showing you how to actually configure first Tableau with the set JDBC driver. In order for a client to connect to GraphDB, they need to go over to SQL Access over JDBC page inside the Usage tab of GraphDB. Keep in mind that this page is accessible from both standard edition documentation, free, and enterprise documentation as well. Here you could actually download the said jar JDBC driver, as I've done currently. And once you download it, you could use this page if you want some other information for configuring it. So now let's go over for the next step to the installation directory of Tableau. As Tableau requires all the JDBC drivers to be placed inside the installation folder for Windows 10 inside the drivers folder, you can see where I have actually added it. And once it's already there, you can start Tableau and connect to it. So now that we have opened Tableau, here we have all the different options for connection. And here we have other databases, JDBC. So let's select JDBC. And here you can see a small panel where you have URL. So this is the actual URL endpoint of GraphDB. So as I have already connected before, you can see it here. You don't need to input username or password if security is off. However, if security is on, you do need to input it. However, as I have turned it off currently, I don't need to. Once you select sign in, it would execute the set activity and you would be able to connect to database GraphDB. So now that we have once connected, here you could see test, which is the name of my repository. And here you can see the 4 different tables which are represented here. So we have client data, education, location, and personal data. Now we'll move forward and load those 4 tables. And actually connect them together. So this is the type of relationship that I was talking about, which resembles the SQL primary foreign key type of relationship, where it actually picks ID of the different tables. Okay, and now that we have loaded the last one, let's move to the sheets where we could actually do a bit of analysis. So let's start with something simple. For example, let's say we want to view in which cities do we actually have clients, which are all the cities where we have clients. And as the data set is for Germany, it is quite concentrated. So we will be using only city here, and we will select the map. Now here we can see the entire map and in which cities we actually have clients. As this doesn't tell us much, it's not very informative. It covers most of the map for Germany. Let's say we want to actually view the density of clients inside each city. So let's say we want them to be viewed by size. So for this, we will need to add ID location size here. And once we do this, we can see that the map doesn't look like much, meaning that we have to change the default measure that Tableau uses. So we go to measure, we go to count, and here we have a result. So now this is much more meaningful. For example, we can see that in Germany, in Berlin, we actually have 3.2 thousand clients inside Berlin. Here we have 1.1 thousand in Hamburg and also 1.4 thousand in München. This is much more meaningful and allows us to actually explore which are our strongest client points inside those inside Germany. Now, let's do another piece of analysis. So, for example, let's say that we want to view customer metrics and compare them around what type of degree did customers go to. So let's say that we want to see what is the sentiment score towards the insurance company by degree. So we'll select degree as well, and we'll see it here. However, the standard default measure for numbers is usually sum, so we need to change it to average. And here we have a much more meaningful result, meaning that we have people studying physics as our customers that are much more sentimental towards our company rather than people studying mathematics who have a quite low sentiment average score. So this could be translated in a number of ways, and further analysis could be done, but for the sake of simplicity for our examples, these would be all the examples that I'll be providing for Tableau. Now I'll move forward and show you how to configure our JDBC driver for Microsoft's Power BI. First, I want to say that Power BI cannot directly connect with a JDBC driver, meaning that you need a JDBC ODBC gateway. For this example, I will be using EasySoft's ODBC JDBC gateway, which you can find a link to on our documentation page under connecting to Microsoft BI. So here we have the tab for connecting to Microsoft Power BI, and here we have a link towards the gateway driver. In order to configure it, for this example, I'll be showing you how to actually create the set gateway. So once you have installed the EasySoft's JDBC ODBC gateway, you actually need to go to ODBC data sources. And here you have to open this tab. So you have user DSN and system DSN. Be careful when using user DSN, as you have to check which user you have logged in order to access the ODBC driver. While if you use system DSN, it is always available. So here I have configured my GraphDB demo ODBC gateway here as an ODBC driver using EasySoft. I'll show you how to add a new one. So we go to create new data source, and here we have EasySoft ODBC JDBC gateway. Once you select finish, another window would pop up where you need to add DSN, which is the name for it, username, password, driver class, class path, and URL. As I have already configured it, I will show you the current configuration for my ODBC driver. So here I have GraphDB demo as the name of the driver. And as I've mentioned before, you don't need to input username and password unless security is on. If security is on, then you need to input it. You also have the driver class, which is always the same. You can find more information about it on the documentation page. We have the class path, which is the path to the jar file. So here you can see GraphDB JDBC remote jar file. And you need to input as well the URL for the actual connection to the GraphDB server. Once you've input those parameters, you can test the connection and make sure that everything is okay. So we select test, and we can see that connection to GraphDB is okay. So we're good to go. So now we close this and we open Microsoft's Power BI. So once we've opened it, we need to go to Get Data, Other, and select ODBC. Once we select ODBC, another window pops up where we can see all the ODBC drivers that we have configured. So we have GraphDB demo here. We select it. Also, there are other options. For example, if you select advanced options, here you can actually input your own custom SQL query for the SQL views, as I've shown you in the presentation. But for the sake of simplicity, I won't be doing this now. I'll select OK. And once we have connected, we will see GraphDB as a database here. So now we select test as the name of the repository, and we can see all the 4 tables that we have defined inside this folder popping up here. So we select client data, education, location, and personal data, and we select load. So while we wait, I want to say that Tableau and Power BI work in a different way. While Tableau loads over time, Power BI loads the entire data upfront, so we are actually able to do operations in memory. And the performance for this is pretty much the same as with a very slight overhead as compared to standard download query for the Sparkle endpoint. So here we can view our 4 different tables inside fields, but we need to define the connections between the 4 tables in order to create a consolidation for the entire data. So here we have 4 ID columns inside these tables that we want to actually connect. So I go to Manage Relationships, and I add the connections to the 4 tables. So first I add client data and education. I connect them by ID. Then I add education and location. And as last, I add location and personal data. So now that we have actually configured the relationship between those 4 tables, we can view the entire data set here. So we have location here, we have personal data, we have education here, and client data as well. Now let's go over to report and do a bit of analysis. So let's say that we want to review different insurance premiums based on people going or clients going to different universities and studying different programs. So we want to review, say, from the customer metrics that we want to view customer loyalty and fraud score as well, based on which university they went to and what degree did they study. So for that, we select scatter chart. Then we select customer loyalty, fraud score, degree, and university. So here you can see the entire analysis on it, and you can see customer loyalty and fraud score by degree and university. In order to make this data more useful, we need to, however, change the metrics as they're currently showing sum. We want average, as otherwise it won't make much sense. And here we also need to add average. And we have our analysis. So let's take this one as an example. So we have somebody studying, so we have clients studying at University of South Wales, and they're studying banking. They have a quite high customer loyalty score, while they have a pretty much average fraud score, meaning that their insurance premium would be actually lower than compared, for example, to this type of clients who study computer science at Technical University of Berlin, as they have a quite high average fraud score and a below average customer loyalty score. We also have clients such as finance at who are studying finance at University of Köln, who have a pretty much low fraud score and low customer loyalty, so they won't be impacted, for example, depending of course on policy, on the type of the insurance premium that they would have. Same goes for example, linear cases such as business administration at Friedrich Schiller University, who have again pretty much high fraud score and loyalty score as well. This is with this example, I will be concluding this demonstration, and we'll be moving forward with a 15-minute Q&A session. Yeah, I will give you 1 minute if you have any questions. Please do not hesitate to ask me anything about configuring the driver or how to actually use it or anything else. Thank you. Okay, so hello again, everybody. In order to answer your questions, first I will start with the one using CSV file. Well, yes, for this example, we imported data through the SQL, through a CSV file with tabular onto refine. Here you could see actually where we imported it. So we have to select, I have created an RDF mapping for it. So we have customer refined CSV. And here you can see the entire data set and how I've actually created the RDF mapping for it. So I have a question where the question is to perform a SQL query, you would have to create a respective SPARQL query. Yes, that is true. You would need to create a SPARQL select query, save it as a .rq extension file, and then it will be available as a SQL view. As I showed in the example, you need to input the metadata right here. So you'd have to add the different pieces of how the different SQL columns would be viewed, and that's how you would actually connect with it. So I have a question where what happens if mail is an array? So how the string would be mapped to an array is actually here, for example, for the mail one, I have actually created for personal data. I have defined it as basically I have used a label for it. So I have provided it not as an array. If it is an array, you would actually have to write the entire array as a in the where clause where gender, for example, equals http.example.com/mail or whatever prefix you want to use with it. So for some of the questions, we will be sending later on for detailed review and answers for all of those questions. In terms of whether you can create RDF file using free version of GraphDB, yes, I'm pretty sure it is possible to create an RDF file using the free version of GraphDB using our own to refine RDF mapping. So I have a question. What happens if the returned SPARQL query result does not comply with the SQL data type? So as I've mentioned before, the RDF to SQL type mapping is actually done on the best effort basis, meaning that if the type doesn't match to the SQL type, then the value would be set to null. As there aren't any other questions, I think this will be all for today's presentation and webinar overall. Thank you for joining in. And oh, sorry, I have one last question. So, okay, is this functionality only available for GraphDB 9.4? Yes, this functionality is available only after version 4 and after version 9.4. Before that, I'm pretty much sure that you cannot connect with the JDBC driver.
Okay, thank you, Thomas, and thanks to everyone who has joined the webinar today. As mentioned earlier, we will distribute the recording in a couple of days. So after that, you can watch and rewatch them at your own pace. And with that, we will say you goodbye and until next time.
Thank you, everyone.
Bye-bye.
Have a nice day. Bye.